killer USB is a commercial name for a USB device that kills the computer. You connect it and it sends 200 volts through the data lines and it completely burns the computers.
Welcome everyone to the Industrial Security Podcast. My name is Nate Nelson. I'm here with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions, who's going to introduce the subject and guest of our show today. Andrew, how are you?
I'm very well. Thank you, Nate. Our guest today is Mario Prieto Sanlés. He is a solution architect at AuthUSB, and we're going to be looking at USB firmware attacks and what we can do about them. These are not just, open the USB drive and click on a malicious file and oops, they got us. These are attacks where the USB device itself is attacking us.
Okay, then let's get into it. Here's your interview with Mario.
Hello, Mario, and thank you for joining us. Before we get started, can you tell us a few words about yourself and about the good work that you're doing at AuthUSB?
Hello, Andrew. Thank you for inviting me. I'm Mario from AuthUSB. I'm a pre-sales engineer, and I worked 3 years ago for AuthUSB. I studied computer science engineer and also higher technician on microcomputer systems and networks. Which we are focused on cybersecurity systems to protect our clients. Here now on AuthUSB, we contact the clients to prevent the company to be attacked with some different kinds of malware attacks or also hardware attacks.
Thanks for that. And, you've used the word USB a couple of times. I've used it a couple of times. We all, vaguely know what a USB is, especially a USB thumb drive. But we're here talking about attacks. Why is USB a problem? How can you attack anybody across a USB? What's sort of the spectrum? What's possible badness-wise on a USB?
For example, the FBI told us to prevent us to connect something to the USB charging ports on the airport, for example, because we can get infect our phone or our iPad or our whatever. For example, we can get infect connecting something to your computer, a storage device, apparently a storage device. You connect to your computer and you get infected. Or for example, you get your device killed by the device. So there are many ways to attack your system. For example, that killer USB is a commercial name for a USB device that kills the computer. You connect it and it sends 200 volts through the data lines and it completely burns the computer. So there are many ways to get infected with the electrical thread, the software thread, or for example the hardware thread that start injecting code in your machine. So there are several ways to attack your system with the USB devices.
So that's interesting. I've heard the word killer USB before. I thought killer USB was software, some kind of software hack. You're telling me it's hardware?
Yeah, the killer USB is a hardware device that have electrical components built inside the apparently normal USB. So when you connect to your computer, the killer USB shares that electrical components and then send 220 volts through the data lines, or maybe just 60 volts through the data lines. So it completely burns the computer. It seems like a lightning strike to your computer that burns the power supply, but in reality it's a USB that kills the motherboard, and it's used to break the first layer of security in the companies
I had some notion already that USBs could be dangerous. The classic, you leave a USB in the parking lot, someone picks it up, brings it into their nuclear facility, and it has Stuxnet on it situation. But this thing where it delivers like voltage to kill a computer I've never heard of anything in that ballpark.
Yeah, I had surprising, I thought I understood attack techniques, but this one is new to me. So I did some reading afterwards, and apparently the way it works is the device has capacitors in the USB drive. You plug it in and it starts drawing power. I mean, USB devices can do that. You can draw power from these interfaces. Draws the power, charges the capacitors, and then discharges the capacitors at 200 volts and fries your motherboard. So, yeah, and these devices are commercially available. You can buy them. They're not apparently illegal. Using them is illegal, but the device themselves isn't illegal. In theory, they're devices that manufacturers can use to test their motherboards and harden their motherboards. In practice, I don't know any pen tester who does this. I mean, why would you go and burn out a dozen of your clients' computers? How can you do that without consequences? But the reading I've done online does include a caveat. It says, basically, don't do this at home, kids.
So has this kind of thing ever actually been pulled off by anybody?
Apparently, one student did use a device like this, burned out 60 computers at their school, videoed themselves doing this, and went to jail for a year. Well, that's nasty. I mean, I really didn't know that. Thank you. I had heard of the charging port scenario. I dimly understand what's happening there, but you're the expert on it. Can you tell us what's happening under the hood in the airport when one of these charging ports is compromised?
The FBI told us we should not connect anything to the charging ports because the bad guys can change the firmware of the charging port. The charging port is built with a chipset or a component that its name is a BMS, is that a component that controls the electricity that needs to be sent to the device. So they can change the behavior of that chipset to infect whatever is connected. Or, for example, do you know bad USB is a commercial name of apparently a storage device, but in reality is a chipset that sends data to the computer. It acts like a keyboard, but physically is like a normal USB. So when you connect that bad USB to your computer, you get infected by some script injected by a cyber criminal.
So I've heard of bad USB before. I thought, you said you could buy it. I thought bad USB was open source, was sort of a demonstration of, for the penetration testers, the demonstration of what's available for what's possible attack wise.
Yeah, but the USB is open source. You can build your own, but you also can buy it like a starter kit with some threads, some scripts that are already injected on that bad USB you buy from the network. So there's a lot of scripts already on, for example, GitHub, that you just need to follow a few steps to configure your bad USB in order to get, for example, passwords or inject a backdoor for the system or whatever. There are already published on GitHub, so you just need to download it.
So bad USB, I mean, can you take us a little bit deeper? What is bad USB? How does it work?
Okay, so when you connect a thumb drive, a normal thumb drive, you see a normal screen with the explorer of what's inside, what is stored on that thumb drive. But when you connect bad USB, you only see, for example, in Windows, in Windows system, you only see the console, the console of the system that is injecting something, but just a few seconds, less than 1 second maybe, that injects something, and that is living on your system. It's a backdoor or a software that a service that is running in your computer. You only see a black screen for a little seconds, 1 second maybe, and when it's closed, nothing's happening, and you only see a thumb drive connected, but you don't know what is happening. There are a lot of sophisticated bad USB with, for example, a electrical component that in the first connection shows Explorer with the software inside. But when you connect later in the second connection, it sends the payload. It sends the script injected on the computer. So there are sophisticated kinds of bad USBs.
Not sure if I missed some crucial bit of detail there, but it sounds like what Mario's describing is more along the lines of the kinds of USB attacks that I'm already aware of.
Yeah, I mean, the classic attack is one where there's a nasty in the data of the USB drive. So, I mean, that was Stuxnet. The structure of the file system entries in the USB drive itself confused the Windows Explorer, exploited a vulnerability, and off you went. The more conventional one is, forget that kind of sophistication. Just put a nasty, hackersareus.exe on the USB and trick someone into double clicking it. Yes, I know it says hackers are us, but that's what you have to click. Click it now. Click there, you're done. It's over. That's the contents. That's, there's gigabytes, tens of gigabytes of space on these devices. If you fill it with malware and you trick someone or trick the computer into executing it, it's all over. This is a different attack. This is where, every one of these USBs has a tiny little CPU in it. People imagine it's a device. It's not a device. It's a computer. There's a CPU in the USB device. It has its own software. That little CPU is executing its own software. That's called the firmware. And normally the software, you connect to the computer, the computer inside the USB fires up and says, hey, I'm here. I'm a storage device. What do you want me to do? And the computer says, well, show me what's in your, what files you got. And it goes back and forth that way. There's a conversation between the computer in the USB and your computer. What's happening here is you connect it up and it says, hey, I'm a storage device. And that conversation starts. And the USB says, by the way, I'm also a keyboard. And it starts typing as if it were an external keyboard on your computer. And it brings up a command window and starts typing into that window for a second or two. You might catch it. You might be glancing away. You might not. The window closes and it has injected a nasty into your computer as if it had typed it from the keyboard.
That seems so remarkable to me. Is there no easy way for a computer to catch that kind of attack before it happens?
Well, this is what we're talking about. We're describing the problem here, but we're gonna see the solution in a minute. This is what AuthUSB does.
Yeah. Okay. So basically, though, the lesson is that besides the contents, the files on a USB drive, it's the device itself too that you have to worry about trust with. So maybe you don't accept a USB on those grounds from anyone besides like a very trusted source.
Yeah, it's worse than that, actually. There's stories out there. Pen testers have published scenarios saying you got to be aware of this because we just did it to our client. The scenario was, the pen testers were tasked with getting into a heavily defended client, and they looked around and said, we just can't get in through these people's network. It's locked up tight. So what they did was one of these, USB things. They went out and purchased a very expensive mouse, a very nice mouse, carefully took the packaging apart, carefully took the mouse apart, inserted a USB drive into the mouse, connected it all up to the mouse's USB, put it all back together, shrink wrapped the whole thing, and sent it to one of the victims in this the company they were testing. Because they'd done some social media research, they figured out this person just came back from an expensive conference and said, "Thank you for attending the conference. Here's a thank you gift." Complete with the conference logo, very official looking. This person says, "Lovely," opens it up. "Oh, this is nice. This is a $200 mouse from my $3,000 conference. Thank you." Plugs it in, starts using it. 12 hours later in the dead of night, it says, "Yes, I'm a mouse. I'm also a USB drive." And, the window pops up and the mouse starts moving, double clicks on the contents, and now the computer's compromised. So it's not just USB drives that are at issue here. If you're given a gift of any USB device, be deeply, deeply suspicious of it.
Imagine that you work in a power plant. You're responsible for a half dozen massive boilers. If a cyber attack makes one of these boilers overpressurize and explode, that explosion will most likely kill you. Which protection from that cyber attack would you prefer? Would you like a mechanical relief valve, one that steam pressure forces open when the pressure gets too high so the steam is released harmlessly? Or would you rather have a longer password on the PLC controlling the boilers? The engineering profession has powerful tools to address physical risk from all causes, including cyber risks. But where is the relief valve in the ISO standard or the Industrial 62443 standard? These engineering tools do not exist in cybersecurity standards. Andrew Ginter's latest book, Engineering Grade OT Security, A Manager's Guide, looks at this topic. You can request your free copy at waterfall-security.com/engineering-grade-OT-security.
So this is all nasty, but this is the Industrial Security Podcast. Can you talk about the industrial environment? I mean, I see USBs everywhere. I mean, what should industrial users be worried about? What should they be thinking about here?
The best way to prevent an attack with USB devices is just don't use them. So in OT environments, in industrial environments, they cannot do that. They need to use USB devices because they have legacy devices where they cannot carry the update or whatever. So they need to use USB devices. They are forced to use USB devices on OT environments.
I kind of expected that. I see people using USBs at industrial sites. I assume it's because they have to, because they're aware of these problems. What's the solution? I mean, if you have to use a USB to load a new, ladder logic program into a PLC, how do you avoid this kind of exposure?
You need something that checks everything that is stored on the device. You need something that when you came with a thumb drive, you connect it to that device, to that system, and it says if it's fair enough to the company, if you can go inside with that thumb drive.
How do we solve this problem? I mean, I see people using USBs at industrial sites because presumably they have to. They have to load a PLC ladder logic program into the device, and the USB is the only way to do it. How do you address this problem?
So the only way you can get protect to these attacks is checking three kinds of threat: the electrical one, the hardware one, and the software attack. You need to check the behavior of the thumb drive in order to detect these three kinds of threat. If you can get that, you are protect of every kind of attack with the USB protocol.
Okay, so there's three things that we have to protect against. We have to protect against the high voltage electrical nasty. We have to do something about the hardware. Can you tell us, what you guys do this? What do you guys do when you say the words electrical hardware and software? When you do this, what does it mean? What do you guys actually do with your product?
Okay, so we develop a device, a hardware device, physical device, which detects the behavior of whatever is connected to our device. So if you connect a killer USB, an electrical thread, when you connect it, we check the behavior, and if it breaks the USB protocol for storage device, we block it, we detect it, we block it, and we also report to the admin that someone is connecting killer USB on the port number one in the device in the company, or on the floor 3 or your company. So the idea is to check the USB protocol that which is very strict. The USB protocol said you need to do this in this exactly time. So if something is connected and don't follow strictly the USB protocol, it means that it's talking with some other components, is talking with, or is typing to the computer, or is charging the electrical components to send the volts through the data lines. So it means it's doing something else that needs to do if it was a storage device.
You check the hardware. If there's over voltage, you block that. That's great. You've checked the USB protocol. It's supposed to be a drive. It's not supposed to be a keyboard. When you say checking the protocol, you've said electrical hardware and software. Is checking the protocol hardware or software? What did we miss something here? I only heard two things. I heard electrical. I heard protocol. What is the hardware? What is the software?
The electrical one is the killer USB that shares the electrical components and then send the bolts through the data lines. The hardware attack is the rubber ducky, the bad USB with all the and then is the software that is this kind of thread. The software thread is a completely normal thumb drive, but with some software, with some malware inside. So we check the USB protocol for the two the electrical. We check the USB protocol for the electrical attack, and we check the USB protocol for the hardware attack. And we have antivirus built inside on our device to check the software attack.
Can you tell me? I mean, how does your device? What does it look like physically? I mean, is this something that I, plug into the wall to have power, and I put my USB in, and it gives me a green light and says your USB is good, go use it wherever you want, and then I go plug the USB into the PLC? Or do I plug your device into the PLC and then plug the USB into your device? Is it between the USB and the PLC, or is it sort of off on the side somewhere?
Okay, so our device is going to be the first layer of security of your company. It's located on the first door of your industrial facilities. So when someone comes to your industrial organization with a thumb drive, they go to the security office with the security guy. He connect the thumb drive to our solution, and from our solution you can transfer the files to the net through the network to your PLC or to the shared folder you want, to the SFTP folder you want, in order to get that files directly from our device without connecting that thumb drive to your computer and exposing yourself to a thumb drive that changed the behavior, for example, at the second connection. So our device is connected to a power supply and also with Ethernet cord to your network.
Andrew, I'm going to need a little bit of help here. I follow how this device handles, typical software threats, right? He mentioned antivirus. But how does it prevent the USB that is going to fry my motherboard?
That's just it. This is a separate physical device plugged into the wall. It does not prevent the USB frying your motherboard. It detects. So you stick the USB drive in there, and it's going to give you a red flashing light saying, whatever you do, don't plug this thing into the PLC. It will fry your PLC. It detects rather than prevents.
Okay, but then why doesn't this USB fry the device itself that's detecting this?
Well, that's the thing. The device is designed understanding that, nasty stuff physically, electrically could be coming at it. So it's designed to withstand electrical abuse. You can design a circuit board for 200 volts. There's things you can do. You have to know what's coming at you. And they've taken this into account, and they do detection. They do antivirus, just like you said. They do the electrical, saying something electrical just happened, and they do the firmware detection as well. Really, what he said was, look, we understand electrically, voltage-wise and signal-wise, electrically, what a normal USB drive behaves like. It behaves at 5 volts. We understand USB protocol-wise what a normal USB drive behaves like. You send it this question, it sends you back that answer. You send it this other thing. You understand the USB protocol for a thumb drive. And so what they're doing is looking hard at what the USB is doing. Is it deviating from the electrical protocol with high voltage? Is it deviating from the drive protocol by saying, hey, I'm a keyboard? Any deviation gives you a red light saying, whatever you do not plug this thing into your industrial network.
Yeah. It also occurs to me now that you're describing all of this that if were the USB to fry this device, which, as you mentioned, it won't because they've prepared for that, that would be a pretty good detection mechanism in and of itself, because they need to have a broken machine, and then you'd probably not want to plug that USB in anywhere. It kind of sounds like an advanced version of something we've talked about on prior episodes, the USB sanitation station, where if you bring a device like that into a manufacturing plant or something, you've got to plug in your USB there, or else you're not going to be allowed to use it elsewhere, but maybe like 1 or 2 extra steps involved.
That's exactly what it is. I mean, you've used the term sanitation station. I've heard the term kiosk. This is a physical device that sits at physical security. You come into the secure zone in the plant, you're asked to empty your pockets. Do you have any USBs? Stick all the USBs in the device. You're not allowed to carry the USBs into the system anyway. It takes the files off the system, puts the files into the network, the clean ones that antivirus has blessed. So yeah, this is a kiosk. It's a sanitation station. It lives as part of your physical security system, sort of checking information and people and devices physically on the way into the secure area. Okay, and so if I have a PLC and the only way to change the ladder logic is with a USB, then what I have to do is take my sort of external USB, my suspect USB, run it through your device, get the files off of it on the other side, and then inside the industrial network, I need a bunch of, color-coded USBs that have never touched the outside world. I put the file back on one of those and I carry it over to the PLC. Is that how it works?
Yeah, we have several modes to work with our product. We have an automatic mode for people who's working on the factory that is only there for working, not for knowing how to use our product or other kinds of products. So we have a mode that automatically transfer everything from the external thumb drive to a internal thumb drive that is protected by you, that is a inventory by you. So it's unknown by our device.
So that all makes sense. Can you give us some examples in the industrial space, in your experience? Who is using these kind of products? What are they using them for? Are they finding anything?
Yeah. Our main clients are big companies with critical infrastructures, also defense and public infrastructures. They find attacks with USB devices. And something that is important from our devices, when you cannot check something, you are not knowing nothing about that door of your company. For example, if you don't have something that checks the email, you are not checking if someone is downloading something from the email. So at this time, nobody have nothing to control what is moving with the thumb drives on your company. So at the first day you connect our product, you start having everything that is running on the thumb drives on your company is reported in real time to a central console, so the admin can check everything that is running on thumb drives. And from there, we have clients that detect someone is trying to inject the company with a bad USB. So that means that you are under attack because the bad USB are built specifically for you. There are not um, they are built by because of you. They are built specifically for you. It's strange to detect the bad USB that is not target to you. So we detect killer USB. We detect. We have clients that detect killer USB and then also bad USB. The software attack is very common. It's normal to have a thumb drive that have that have malware inside. So the most important is the most important to detect and block and also report is the electrical and the hardware attacks.
So that was a long answer. Let me summarize. What I heard Mario say was that their systems in use, and most of their customers are large critical infrastructure sites. Their systems have detected all three kinds of attacks. The most common attack that they detect is the stuff that the antivirus catches. There's a nasty in one of your files in the 600 files on the drive, and quarantine it. So that's sort of commonplace. He also said that the killer USB, the high voltage, has been detected in the wild, which surprises me. I would have thought that, if that was going on in the wild, you'd hear more about it. And, this is the first I've heard of it. So that's a bit of a surprise. He also said that the firmware attacks have been detected in the wild. And these are, in a sense, particularly alarming because he says in practice, when they've been detected, pretty much always they have identified a targeted attack, meaning someone with a lot of resources put together an attack that is specific to this critical infrastructure site or that, very valuable industrial site. Who has those kinds of resources for that kind of investment in attack technology? It's usually a nation state. So that's disturbing that these have been discovered in the wild as well.
Yeah, it strikes me that these kinds of attacks wouldn't be cyber criminal in nature, but also that I haven't really heard about them before. Is there a reason why they wouldn't make the news?
You have to ask who's detecting these attacks. If it is nation state, it may well be, nation state attacks on very sensitive targets. He did not say that they have, military customers. If you've got a very sensitive target, if let's say a large government-owned facility, whatever kind of facility it is, they might just not report, hey, we think the Russians or Iran or someone, North Korea has just come after us. They might share that knowledge within, they're classified within their circle of people that they inform confidentially about these attacks to say, here's what's happening, protect yourself. But if the man on the street is not at risk of, a nation state coming after them, maybe they figure they don't need to know. And the people who do need to know, our allies, have been informed through classified channels. I don't know. I don't have a security clearance. I never see any of this. So this is all speculation on my part, but it seems plausible. So on the industrial side, let's take a step back. On the industrial side, the USB attack everybody talks about is Stuxnet, a very sophisticated attack, nation state grade. How confident should we be of the AuthUSB solution? Can you detect, that grade of sophisticated attack?
We are confident on our solution because of we check the behavior, but the confident that a client needs to contact us is we are certified by our Spanish cryptological center. And also we are approved and also certified. There's two options here: certified or approved. We are both. We are certified and approved to work with our Spanish national cybersecurity scheme, and also we are certified to work with NATO countries. We get through a reverse engineer program in order to certify, and we are 100% made in Spain. We don't use electrical components from outside of the European Union. So that's the confidence we send to our clients.
So that's good. You guys have been, doing this for a while. Can you give us any view into the future? I mean, where's this going? What are you guys doing next?
The version we have today is the third version. We started this company in 2018. 2018. This is the third version that we are working on the new versions with more ports. The model today have 2 ports through to version 3 of the USB protocol. And we are working on the different kinds of devices, everything to detect USB attacks, but different kinds of the devices with maybe a screen or with more connectors, Type-C version to support USBs with Type-C, or we are working on more than one device, more than one model.
Well, this has been great, Mario. Thank you for joining us. Before we let you go, can you tell our listeners what should they be taking away? What should they be watching in this USB space?
The first thing is never trust USB devices. It can look like a thumb drive, like your friend's thumb drive, but in reality, it can be anything. It can be a keyboard, it can be a Bluetooth connection or a Wi-Fi connection. So beware of thumb drives, because it's the first thing the cyber criminal tries to do, because it's cheap. And is the fastest way to get inside your system. So the second thing you need to know is our goods from the AuthUSB is that we are focused on those environments where they need to use USB devices every day for every action, and we are checking the behavior. We are the only ones that check the behavior of the USB devices. Other looks on the blacklist or whitelist. We just check the behavior of whatever is connected. And we also report everything in real time, so the admin of your company can see everything in real time. So if you want to know more about our solution, you can just contact us with our website. It's authusb.net. And from there, you can contact and know more about our solutions.
All right, that seems to have concluded your interview with Mario. Andrew, do you have a final thought that you can take us out with?
Yeah, I mean, something Mario said in sort of his sum up reminded me, we've talked about sort of, in a sense, the mundane, the normal, the kinds of attacks to expect. He reminded me that these kinds of attacks can become much more sophisticated. Imagine something these USB drives, they've got CPUs inside. They can be arbitrarily complicated. They can be arbitrarily powerful because they're little computers. Imagine a USB drive that has a CPU inside, yes, and, I don't know, cellular hardware. So it can reach out to the cellular network and say, here I am. What would you do with that? Well, it could say to the computer, hey, I'm a drive, great. I'm also a keyboard. I'm also a mouse. I'm also a screen. And what's the default behavior on most Windows computers when it says, "Hey, I'm another screen"? It mirrors the first screen to the second screen, and now you're seeing a copy of the screen. You can move the mouse, you can type in the keyboard. This is nasty, but all over the internet, all by remote control. The bottom line here is that we need to be deeply suspicious of any USB drive that comes into our industrial network from the outside world. We need to scan it 9 ways to Sunday, on the way into the network, ideally pulling the contents off of it, not allowing the physical device into the network at all. It's a modern threat. It's, thank you to Mario for reminding us of this nasty attack pathway.
Yes, thank you to Mario Sanlés for speaking with you, Andrew. And Andrew, thank you, as always, for speaking with me.
It's always a pleasure. Thank you, Nate.
This has been the Industrial Security Podcast from Waterfall. Thanks to everyone out there listening.